Hi, in this video we're going to continue our study of functions and we're going to graph some piecewise functions. So a piecewise function is a function such as this one that is defined in two different pieces. So we'll call this function f of x. So it's defined to be the line 2x plus 1 for x's that are less than 0, and then the parabola x squared takes over when x is greater than or equal to 0. So let's practice finding some values first. So say that I want to find, let's try f of -2, f of 1, let's find f of 0, f of 10, and let's try another negative number. How about f of -5? So if I wanted to find all these values, so let's start with f of 2. -2. So when I look for f of -2, based on the x, right, in this case my x is equal to -2. So when I go to the pieces, I see, okay, x less than 0. This is essentially saying when x is negative. And x greater than or equal to 0 means when x is 0 or when x is positive. So when we're finding f of -2, I'm going to be looking at the part where x is less than 0, since x is -2, that's less than 0. So I'm going to plug it into that portion. So I'm going to have 2 times -2 plus 1. So 2 times -2 is -4 plus 1, so I'm going to get -3. And so we're going to the next one, f of 1. So if I want to find f of 1, so now I got to look at, okay, here x is equal to 1. So I go to my pieces, x is 0, x is positive. So when x is 1, 1 is greater than or equal to 0. So I'm going to be looking at the bottom function, the x squared. So this is going to be 1 squared, which is 1. In terms of coordinate points, right, this one is the coordinate point. X is -2, y is -3. Remember, f of something, that's giving us the y value corresponding to the x. So for f of 1, what we just found is the coordinate point. When x is 1, y happens to be 1 as well. F of 0 is the next one. So f of 0, here x is equal to 0. So which piece are we going to follow? X, and so that will be the bottom one, where x is allowed to be 0. Notice that the top one does not have an equal, so x can't be 0 there. So f of 0 is going to be 0 squared, which is 0. So the coordinate point is 0, 0. And moving on, f of 10 and f of -5. So f of 10, 10 is a number that is greater than 0. Right in here, x is 10. So I'm going to have 10 squared. So we're following the x squared piece because we follow that piece when x's are greater than 0. 10 is greater than 0, so we follow the x squared piece, and 10 squared is 100. So this gives us the point when x is 10, y is 100, and so on. So the other one, the last one, is f of -5. Now f of -5, here x is positive or negative. Right, and notice that x is negative. X is -5. So going back up to our function, when x is negative, we use the top piece, the 2x plus 1. So this is going to look like 2 times x. X is -5 plus 1. So that's -10 plus 1, which is -9. Giving us the coordinate point, x is -5, y is -9. So that's how you evaluate function values. Now I did ask to graph it, and so graphing it is a different story. Well, we can still use our points found and plot, so I could plot all these points that I found, but we're going to do it by looking at the individual graphs. So my function, let me just rewrite it, is f of x is 2x plus 1 when x is less than 0, and x squared when x is greater than or equal to 0. So normally what I do is I look at the pieces individually. So when y equals 2x plus 1, what does this look like? And that is a line with y-intercept of 1 and slope of 2. So 1 is a y-intercept, and the slope is 2, so we're going to go up 2 and over 1, and so on. So we connect the dots. So this is what my line will look like for y equals 2x plus 1. Now the function says we only want it to look like this line for the x's when x is less than 0. So this is just as we did before, when x is negative. So that means here's 0. So I only want this part of the graph when x is negative. And I am not going to include the intercept. Okay, we don't include the y-intercept. So the other piece is y equals x squared. So what does y equals x squared look like? Well, y equals x squared is our parent graph parabola. And the piecewise function says we only want that when x is greater than or equal to 0. So when x is positive. So x is positive on the right side. So that means we're going to want this part of the graph. So this is what we want. And we want to include 0, 0. Including 0, 0. So when we graph it, putting it together, so the graph of f of x is going to look like, and I'm going to try to color match them here. So it looks like y equals 2x plus 1 on the negative side, so not including the y-intercept. So I'm going to have an open circle there because we're not including it at 1. And it goes down. So this is my y equals 2x plus 1. And then when x is positive, we look like the parabola, this blue part that I circled. So I'm going to go to the vertex 0, 0, and we fill it in. And we have y equals x squared. So these two pieces together make the graph of f of x. And notice that f of x is a function, so we should be able to pass the vertical line test where each point in the domain, each input, right, has exactly one output. That's what makes it a function. Okay, so, and notice that if we go back to our function values, f of -2, we said is -3, so the point -2, -3 should be in the red portion of the graph, which it is. So -2, -3, this is not drawn to scale, but it will be around here. Put it with my color, so -2, -3 will be somewhere around here. And then notice that for the things that are greater than 0, so f of 0 is 0, and then say like f of 1. Over here, f of 1 was 1, 1. So here is our 0, 0. And if we go 1, this is the point 1, 1. So notice that the function values that we found before are matching up. If I go to 10 way over here, it's going to be 100 way somewhere up there. And that's why this arrow keeps going on. That indicates that it keeps going on forever then. So let's try another one. So say a different example. Let's graph, and I'm going to call it g of x. X squared minus 1 when x is less than 1, and negative x plus 1 when x is greater than or equal to 1. So notice the difference here. Well, the functions are different, but also before we had at 0 is where we had the two pieces change. Now we have them change at 1. And so let's practice again, finding some values. So say I want you to find f of 0 and f of 3. So how would you find these? So f of 0, you got to look at your x value. X is 0. So where does 0 fall in the pieces? When x is 0, 0 is less than 1. So we're going to be looking at the top piece, that quadratic. So f of 0 is going to be 0 squared minus 1, which is -1. So that will give us the point 0, -1. F of 3 will be 3 is a number that is greater than 1, right? I have to go back to my pieces. The pieces are put together at 1. So whenever I pick my x, I have to ask myself, okay, is my x less than 1 or greater than 1? Because that dictates which piece we're going to use. So because x is 3, which is greater than 1, then we're going to use the bottom piece. So this is going to be negative x. So -3 plus 1, which is negative 3 plus 1, which is -2, which gives us the point 3, -2. Okay, so you can plot points to try to graph the functions, but I find it visually that if I graph the two functions individually and then piece it together at 1, it's a little better than plotting points. So let's look at what each of them do individually. So my pieces are made up of y equals x squared minus 1. So what does this one look like? And the other one is y equals -x plus 1. So what does that one look like? And then we'll put it together here for g of x. So x squared minus 1, that's a parabola. But now it's moved down to -1. So the vertex is at 0, -1. So before we had just x squared, so it was at 0, 0. The -1 makes it shift down. And now remember the split point happens when x is 1. So when x is 1, what does this function look like? When x is 1, y is equal to 1 squared minus 1. So it'll be 0. So it's going to be over here. So this is when x is 1. Now remember the function said I want to look like x squared minus 1 when x is less than 1. So everything smaller than 1. So that means we're going to take the left side of this parabola. So we're going to take this, and do I want to include x equals 1 or not? So let's go back and see. No, it doesn't have the equals, so we will not include 1. So I'm going to say not including the 0.10. Now, what does -x plus 1 look like? -x plus 1, that is a line with a y-intercept at 1, and the slope is -1. So we're going to go down 1 and over 1, down 1, over 1, or up 1 and to the other side 1, and then you connect the dots. So this is y equals -x plus 1. And we want our function to have a piece of this function, or this graph, when x is greater than or equal to 1. So when x is greater than 1, that means bigger. So to the right of 1. So we're going to be taking this portion, and it did have the equal, so I do want to include that point. So including, and what is that point? So our split point was when x is 1. So when x is 1, what's y? Y equals -x plus 1. So -1 plus 1, which is 0. So it happens to be the same point. So including 1, 0. So that means, let's go put it together. So you will see what happens here. So as we put it together, so g of x here is the function x squared minus 1 when x is less than 1, and -x plus 1 when x is greater or equal to 1. So I'm going to go to 1, because that's where my pieces are put together. And to the left of one, we're going to take the parabola. So we're going to go parabola and come back. And it says not including. So normally I will put a circle there and leave it open because it's not included. Then I go and draw my other piece. When x is greater than or equal to 1, we're going to use the blue portion that I circled here from the graph of negative x plus 1. But notice that the point happens to match up. So that means that I'm going to come to that open circle and I'm going to fill it in. And then we're going to continue the graph. So this is y equals negative x plus 1. And this one is y equals x squared minus 1. So together, those two pieces make the new function. And that is graphing a piecewise function. You could also do it by plotting points, but you just have to plot a lot of points to be able to get what the graphs look like, especially after the split point. So it is best to know what the graphs look like individually and then put them together.